Alright, here's our video today, or tonight, in the morning, or then twilight. What do you see? Do you see twilight? Do you see dusk? Do you see dawn? Is it morning? Or is it the end of the day? Hard to tell, right? Very hard to tell. In fact, the only way you know is if you know what direction you're looking at. If you're looking at the east, we know it's dawn. If you're looking at the west, well, you know it's twilight. It's a good time to have coffee. Good time in the morning to have coffee. Good time in twilight to have coffee. So that's not going to help us, right? We can yawn at dawn. We can yawn at twilight. But there is subtle differences, and we're going to talk about that. And we'll also talk about why we're seeing red, the red and the yellow. So when we're talking about dusk or dawn, well, let's just call it twilight. I like that word better. Let me get my pen. Let me make the pen working over here. And there's many phases of dawn and twilight, astronomical twilight, and so I have videos on that if you want to look it up. But if we're looking at dusk or dawn, they're just opposites, right? The sun appears to be at certain angles, and they're the same angles at dawn and the same angles at twilight. So we can't look at the angles of the sun to help us. Again, we just need to know the direction. But there are subtle differences. So let's look at twilight. Twilight. And again, there's three forms of twilight. In twilight, the colors are more intense. They can be, not always, they can be more intense. And there's a reason for that. We'll talk about those reasons, right? They can be more vibrant. And one of the reasons why is in the evening, at twilight, in the evening, put a little arrow here. Evening air, in the evening, the air can hold more moisture. Well, we should say there is more moisture in the air in the evening, most of the times. Mostly through evaporation, right? So we have evaporation that's happening throughout the day. That's one reason. So there could be more air. Well, not more air. There could be more moisture in the air in the evening. And also, in the evening, there could be more scattering effect. So, in the evening, there is more of a scattering effect. And we lost the R in there because it's scattered. And we know that when light hits the atmosphere, it has different wavelengths. Red is the longest wavelength of visible light, and violet is the shortest wavelength. So, and the sun, it produces more blue light, and we see blue light better than violet light. So violet light scatters more, right? It enters the atmosphere and it has this immense scattering effect. And so the red and the yellows and the oranges, they take longer to scatter. And we'll go over that. So the one thing we talked about right now is that in the evening the air can hold more moisture, and that could add to the colors being more rich, more vibrant. But also in the evening, because of traffic and human activity, you can have more smog and pollutants. And those pollutants and smog could add to the scattering effect, making the colors more rich and vibrant. So we have moisture in the air, smog and pollutants, and of course at the end of the day, all that traffic coming home. Of course, there's traffic in the morning, but then there's the human activity of the factories and so forth. Could add to that color enrichment. So if it's either twilight or dawn, right, the sun appears on a horizon, right? That's where it seems to appear. But if we look at it from our perspective, if we look at Earth over here, try to make a round ball, and let's just say that's the sun. Obviously, we know the sun is much, much more bigger than Earth. But if we look at its light coming down, its visible light coming down, and let's say that we were, let's use this blue. Let's say we're over here. Well, that's not working. We want blue. There we go. Let's say we're over here. And let's just say this is morning. Doesn't matter. It could be morning or evening. The same effect is happening. And we'll go back to our sunlight. So over here, in this part of the day, it's midday, and here we're starting morning. We're just starting our day. So we can see the blue light would scatter faster, so there'll be much more blue in this area. And the longer wavelengths of red are finally getting to us, and that's why we would see it as red. And I'm just going to use yellow, the reds and the oranges. Reds, the yellows, the oranges. We're seeing that effect. So again, the blue enters the atmosphere, it scatters in all directions, but the red light has a longer wavelength, and the orange and so forth. And so by the time it gets to us, it gets to our vision in the morning, we see those reds, and we'll see them in the dawn and in the dusk. So, as we said, what do you think? Is it dusk or dawn? Well, this is a picture of dusk. This is twilight, and you can see some rich colors in it. But that doesn't always happen, right? So you may be fooled if it's dawn. You may be fooled if it's dusk. That is, if you're looking at a picture. Hopefully you're not fooled not knowing if it's dawn or dusk when you wake up. Well, that's our video today.